Good morning, children.
Good morning, ma'am.
See, actually, we are doing problems from the chapter areas related to circles. Few more questions are there. Once we complete that one, we'll be okay. Most probably within this period, we'll be completing this chapter areas related to circles. Okay. Now write this question. Write this question. Is it clear? Can you say this? Ashik?
Yes, ma'am.
Write the question. Calculate the area of the designed region. Calculate the area of the designed region. Calculate the area of the designed region, which is common between two quadrants. Which is common between two quadrants of circles. Which is common between two quadrants of circles of radius 8 centimeter each. Of radius 8 centimeter each. Calculate the area of the designed region in common between two quadrants of circles of radius 8 centimeter each. Calculate the area of the designed region in common between two quadrants of circles of radius 8 centimeter each. Okay. Okay. Now listen, children. Okay. Before we do the problem, tell me what is the formula for area of the sector. How will you find the area of the sector? Formula to find the area of the sector.
Theta by 360 into pi r square.
Very good. Theta by 360 into pi r square. And what about area of the segment? How will you find the area of the segment?
Theta by 360 into pi r.
Theta by 360 into 2 pi r. Segment.
Area of sector minus area of triangle.
Very good, Adil. Okay, area of the sector minus area of the triangle. Okay, area of the segment is area of the sector minus area of the triangle. So now look at the figure here. Okay, so it is given, initially you are given with a square, isn't it? We are given with a square. It is given as a square. And what is given? Okay, you are given with a square. And what is given? Both. Okay. Okay, so it is given. So here it is given as the region is given as it is the section included between. Okay, if you take this part, if you take this one part, it is given as a square. Look at the figure given there. ABCD is a square of side 8 centimeter. and this part is designed. Okay, if you take this, only if this part, if you consider, it is a sector with angle 90 degree, and this part is designed. Yes or no? This is how the figure is given. Similarly, if you take the other side, from the other side, if you take this side, if you take this part, you'll get this as a quadrant, and this part is shaded. Is or no? Is or no, children? Are you able to understand? Okay, so it is given like this. Suppose this is a sector. In this sector, one part is shaded. Similarly, we have another one. Okay, so here this part is shaded. So combining these two, we will be getting a shape like this. We are asked to find the area of the design. How will you find the area of the design? So area. Yes, very good. Area of the design is equal to area of two segments. We have two segments here. Okay, it is area of two segments. Okay, this is one segment and this is the other segment. Two segments are there. So area of the design is equal to area of two segments. And how will you find area of segment? Area of the sector minus area of the triangle. Area of the sector minus area of the triangle. Now look at the sector. In this sector, what is the angle? What is the angle you have? 90 degree, isn't it? It is given as 90 degree. So it will be a quadrant. So instead of sector, we can write this as area of quadrant minus area of triangle. So area of triangle, here it is again a right angle triangle. It is 90 degree. It is 90 degree. So it will become a right angle triangle. Now area of the quadrant, the formula is pi r square by 4 minus. What about area of the right angle triangle? It is half into base into height. So half into, we can take the base as DC. Into height, we can write it as AD. Half into base into height. Then substitute the values. If nothing is given about pi, pi is 22 by 7 into r. Radius is given as 8. 8 square by 4 minus half into 8 into 8. Now substitute the values and simplify. You'll get the area of the design. Area of the design in centimeter square. This is the area of the design in centimeter square.
Ma'am, two segment is there, right?
Yes, here, yes, yes. Area of two segments. So we have tried 2 into 2. Into 2. Two into. Okay, two segments are there. So we have to multiply that by 2. Yes, what is the answer? Calculate and give the answer. Amina, what is your answer?
Ma'am, I'm going through answer.
How to do this? Listen, children. The easy way to do is, I'm going to take 8 square as common. Okay. How will you simplify? You can do it by expanding and all. But what is the easy way? What is common? You take it outside. So I think 2 into 8 square by 2, I will take it as common. So it will be left out. 22 by 7 into 1 by 2 minus 1. Is it correct? Is it like this? I'm taking, okay, from these two terms, what is common? You take it outside. So 8 square by 2, we can take as common. So 2 will get cancelled. So it will be 8 square into 8 square into here again. So we'll get 11 by 7 minus 1. So 64 into 4 by 7. So that's the answer. What is the answer, Rose?
Ma'am, I got 401.142.
401. What about the others? Okay, in fraction, can you give the answer, Melvin?
2,808 by 7.
No.
Ma'am, 256 by 7.
Yes, 256 by 7 is the answer. 256 by 7 is the answer. While doing calculation, if you take the common terms outside, your expression can be, okay, you can reduce it. You can reduce the minimum, solve it by minimum number of steps. Melvin, check your answer. Maybe I think you might, this 8 into 8 into 2, somewhere some mistake you have done. From here, redo it again. Okay, write the next one. Write the next question. Write the 8th question, children. Write the 8th one. 8th one, draw the figure. Draw the figure also. Figure 12.26 depicts a racing track whose left and right ends are semicircular. Write the question. Okay, the following figure depicts a racing track whose left and right ends are semicircular. Whose left and right ends are semicircular. The distance between the two parallel line segments is 60 centimeter. And they are 106 meter long. If the track is 10 meter wide, find the distance around the track along with its inner edge. Second one, the area of the track. Eighth question. Okay, this figure no need. Okay. Yes.
Can you repeat those things?
Figure 12.26. Figure 12.26 depicts a racing track. Figure 12.26 depicts a racing track whose left and right ends are semicircular. Okay, whose left and right ends are semicircular. The distance between two inner parallel line segments is 60 meters. And they are 106 meters long.
Ma'am, we should draw this figure.
Yes, we have to draw. If we draw this only, we'll be able to calculate.
And this two figure we have to draw.
No, figure 12.26 only you have to draw.
Yes,
Okay.
ma'am.
This figure we did. Okay, last class we solved this one. So only the first part, figure 12.26. Figure 12.26 only we have to draw. If the track is 10 meters wide, find the distance around the track along its inner edge and the area of the track. The area of the track. Finished? Is it okay?
Ma'am, do we have to write that sub questions?
Yes, that is what we want to find. Okay, that is what we have to find. So we have to write the sub questions. In the main question, nothing is there. Okay, in the main question, it is given just that it is about the track and it is semicircular at the ends. The distance between two inner parallel line segments is 60 meters and they are 106 meters long. If the track is 10 meters wide, find the distance around the track along its inner edge. Second one is area of the track. Yes, you copied?
Yes, ma'am.
Yes. One of you read the question again. Yes. Arjun, read the question, Arjun. Arjun? Arjun, can you hear me? Arjun? Yes, Bhadra, read the question, Bhadra. Bhadra?
Depicts a racing track whose left and right ends are semicircular. The distance between the two inner parallel line segment is 60 meters and they are each 106 meters long. If the track is 10 meters wide, find the distance around the track along its inner edge, the area of the track.
Okay, now listen, children. Okay, this is how the figure is given. Okay, look at here. It depicts a racing track whose left and right ends are semicircular. Suppose I draw a line like this, means you can see the left and right ends are semicircular. The distance between the two inner parallel lines is 60 meters. So these are the two inner parallel lines. So the distance between these two inner parallel lines is given as 60 meters. If the track is, and they are 106 meters long, okay? So this length, okay, I'm naming all these ends. Listen, children, don't write, first listen. This type of questions will be asked for case study. So I name it, okay? I'm naming this corner points here, A, B, C, D. And here, E, F, G, H, okay? You can name, you can give any alphabet. And what is given? This length track is, inner edge is 106 meters long. The inner track is 106 meters long. That means the length of AB and CD is 106 meters long. If the track is 10 meter wide, this width is given as 10 meter. Track means this is the part, isn't it? So the track is 10 meter wide. First one, find the distance along the inner edge. We want to find the distance along the inner edge. Second one is area of the track. So first thing is we want to find the distance along the inner edge. Distance along the inner edge. Distance along the inner edge. Listen, all of you. Listen. If you want, okay, suppose we start from the point A. Okay, suppose we start from the point A. We want to find the distance along this inner edge. So we want to find that is same as this perimeter we want to find. So if you start from the point A, it is AB. Then BC, it is the curve BC, arc BC. So I represent like this, BC, arc BC. We have learned it in our lower classes, how to represent an arc. Then CD, CD is the straight line. Then again DA, DA is the arc plus BA. Is it okay? Is it clear up to this? Okay, now look at here, AD. What is the shape of AD? Is it a semicircle? Is it a semicircle? So the diameter AD is given as, what is the length of diameter AD? It is 60 meters. Is or no? Therefore, what will be the inner radius? Suppose we denote this inner radius as small r. Therefore, the inner radius small r will be, this is 60, isn't it? So it will be 30. 30. So this one also will be 30. So inner radius will be 30 meters. AB and CD are equal in measure. Okay, AB and CD are two parallel sides. So we can write this as 2AB plus 2BC. Is it correct? BC and AD are semicircles of the same radius 30. So instead of calculating BC and DA separately, both are equivalent. So we can combine it and we can write this as 2BC. So now substitute the values. 2 into, what is AB? AB is 106. So 2 into 106 plus 2 into BC. BC is semicircle. What is the circumference? Only this outer edge we take. So it is pi r. Is it correct? Is it pi r? If you take the full circle, it is 2 pi r, isn't it? And Mary, if you take semicircle, it will be? Is it correct, Anne Mary?
Yes, ma'am.
Yes, that is 2 into pi r. So that is 2 into 106. So when you multiply this, 212 plus 2 into 22 by 7 into 30. Simplify this, you will get the answer in meters. Try this one. So this is first part only we have tried. We are finding the distance along the inner edge. We are finding the distance along the inner edge. Okay, first you draw the figure, name all the vertices here, A, B, C, D. So you start from the vertex A, B, then curve BC, then straight line CD, again arc AD. Is it okay, Rose? Is it clear, Rose?
Yes, ma'am.
Badra,
Yes, ma'am.
Prajot, Meghna. Okay, these questions will be asked for case study. The figure will be given. Okay, it's simply a track, but if you look at the track, we can divide like this. Now substitute this and find the value of m.
4,320 meters square.
4,000. Denominator and all, will it get cancelled?
Yes, ma'am.
How?
2,804 divided by 7.
Yes, 2804 by 7. So how will you do? Okay, what is the final answer?
Ma'am, 4,320 meters square.
No, 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 no. It will not get divided. Check it. Okay, if you do, yes. Yes,
2804 by 7 meter. That is
Two-
the answer.
2824.
No, ma'am, 2804 by
Yes, 2804 by 7. You can stop with this. Okay. 2804 meter by 7 meters.
Ma'am, definite truck.
Area, okay, we are not at calculated. Sub to this, is it okay? Emil? Vishnu? Emil? Vishnu? Is it clear? Is it okay? Vishnu? Okay, now shall we do the second part? What is asked in the second part?
Area of inner
Area of the track, isn't it? Okay. So first part we completed. Now second one, finding the area of the track. Okay. So to find the area of the track, listen children, so the second one. Okay. That track, we can divide it into 4 parts. We can divide the track into 4 parts. Okay, which are the 4 parts? If you take this first part, what is this first part? Can you identify the shape here?
rectangle.
Rectangle. So we have 2 identical rectangles here. 1 and 2 will be identical. Okay. And look at the other part, which is the other one. You take the other side. This is the third one. It is the area enclosed between these 2 regions, isn't it? This is our third part. Okay, and this is identical with these 2. Fourth one. Okay, so area enclosed between 2 semicircles. So we want to find the first part. So first question is area of the track. Area of the track will be same as, we can divide it. Okay, I'm naming this as A1, A2, A3, A4. We have to add all these 4 areas. A1 plus A2 plus A3 plus A4. But A1 is same as A2. A1 and A2 are identical. A3 and A4 are identical. So we can write this as 2 times A1 plus A3. Is it correct? Savio, is it correct? 2 times? A1 and A2, is it same?
Yes, ma'am.
So we can, instead of writing A1 plus A2, we can write this as 2 times A1. Similarly, A3 and A4 are identical, same. So we can write this as 2 times A3. So it is 2 times A1 plus A3. So let us find out A1. What is A1? Look at the shape A1. It is a rectangle. It is the area of rectangle. It is a rectangle, and area of the rectangle, we know that length into breadth. So what is the length? What will be the length here? Is it 106?
Yes, ma'am.
Into breadth. Breadth will be same as the width. It is 10. So it is 1060 meters square. Now we want to find the A3. We want to find A3. So A3 will be, how will you find A3? It is same as area of bigger semicircle
minus area of small semicircle.
Very good. Minus area of smaller semicircle. Okay. What is the area of bigger semicircle? So we can take, suppose we take the outer radius r, pi r square by 2 minus pi small r square by 2. So we can take pi by 2 as common. So it is r square minus small r square. What is capital R? That is the next question. What will be the bigger radius?
30 plus 10.
Very good. 30 plus 10. This is 30, isn't it? This length is given as 30 and the width is 10. Width is 10. So 30 plus 10, it will be 40. So it is pi by 2 into 40 square minus 30 square. Pi by 2 into 40 square minus 30 square. So that is 22 by 7 into 1 by 2. A square minus B square. So it is 40 plus 30 into 40 minus 30. So 1, 2, if you cancel, it is 11. 11 by 7 into 70 into 10. So it will get cancelled. 7, 10, isn't it? So it is 1100 meter square. It is 1100 meter square.
Ma'am, we should take the other side also.
Which one? A4. Is it fourth part?
Yes,
Fourth,
ma'am.
fourth one is identical, isn't it? Similar only. So no need to calculate. Instead of that, both are same. So we can take it as 2 times A3. Is it okay? A3 and A4 are same. So no need to calculate it again and again. So after completing this, you substitute this in the area. Area is 2A1 plus 2A2. So it is 2 times 1060 plus. What about the area of the third part? Area of the third part is 1100. And simplify, you'll get the area of the track. This much meter square is the area of the track.
4,320.
4,320. Sorry. (4,320 meters square is the answer.
Yes, ma'am.
Okay, so these questions will be asked. There is a chance for asking these questions and all for case study questions. Okay. Is it okay? Badra, Rose, Afsana?
And can you show the slide again?
We'll be continuing with that question in the next period.
Yes,
Thank you.
ma'am.
Thank you.